Hello everyone, I am Prabhakaran Ramachandran. Today, our group will present a mathematical model that uses determinant to solve a real life problem. This is an application of determinants, which is one of the key topics in algebra. We have a simple story. Three friends bought three different drinks coffee, tea, and juice. We don't know how many of such drinks they bought, but we know three facts from their order. First, total drinks are six. Second, coffee plus juice exceeds tea by two. Third, twice coffee plus tea minus juice equals 1. These facts gives us three equations, which you can see on the screen. Let x be the number of coffee, y the number of tea, and z the number of juice. The equations are shown on the screen. Now we want to find x, y, and z. To do this, we'll use Cramer's rule, which is a method that uses determinants to solve a system of linear equations. The formula is also shown on the screen. Here's how we'll proceed. First, our team member Beck will set up the matrices and compute the determinants of the coefficient matrix. Then our next team member Zuhairi will use Cramer's rule to find the number of each string. Finally, we'll summarize how determinants help solve real problems. Now, I'll hand over to Beck, who will set up the matrices and compute the determinants of the coefficient matrix. Thank you very much.
Thanks, Prabha. Hello, I am Beck from Ting. Now, let us write the system in matrix form. The coefficients matrix A and the constant matrix B are shown on the screen. The first step in Cramer's rule is to compute the determinant of A. We will do this by expanding along the first row. The full working steps are on the screen. I will walk you through them. We expand along the first row. Computing three 2 by 2 determinants, the calculations are displayed. Adding them up, we will get determinant A equals to 6. Now, because this is not 0, we know the system has a unique solution, and that is important. Now I will pass to Zuhaidi, who will finish the calculation using Cramer's rule.
Thank you, Beck. Hello, my name is Muhammad Zuhaili bin Muhammad Razif. Now we move to the application part of Cramer's rule. We need to replace each column of A with B one by one and compute the determinant of those new matrices. You can see all three matrices on the screen. For X, the matrix A is shown and its determinant is 6. So X equals 6 divided by 6, which is 1. For Y, the matrix A is shown and its determinant is 12. So Y equals 12 divided by 6, which is 2. For Z, the matrix A is shown and its determinant is 18. So Z equals 18 divided by 6, which is 3. Therefore, to answer your original question, how many of each drink did the three friends buy? The answer is they bought 1 coffee, 2 teas, and 3 juices. To conclude, this simple model shows how determinants can be used to solve real-life problems. If the determinant of A had been 0, the system would either have no solution or infinitely many solutions. But here is non-zero. Therefore, we have a unique, reliable answer to how many of each drink the three friends bought. Cramer's rule is especially handy for small systems like this, and the concept of determinants remains central to linear algebra. Thank you for watching. This is Prabha, Beck, and Zuhaili sign off.